Hi, I'm Lane Brooks with National Design Build Services, also known as NDBS. We are a mechanical HVAC design build contractor that does 100% of ARCO's work, or close to it. And today we're going to be talking about energy codes.
There are two different energy codes that can be used to prove compliance. You can either use the International Energy Code or ASHRAE publication. ASHRAE is just American Society of Heating, Refrigeration, and Air Conditioning Engineers. Within the International Energy Code, it references ASHRAE, so that's how that can be used. You can look at the International Energy Code for free online, but ASHRAE you have to buy. So what's regulated? The envelope of a building, walls, doors, insulation, or electrical, lighting, types of fixtures, watts per square foot are regulated. For mechanical, which we deal with mostly, the efficiency values of heating and cooling equipment, efficiency values of motors, some outdoor air requirements, thermostat placements, CO2 sensors as far as like break rooms and other things. We need to have CO2 sensors to make sure there's enough outside air for everybody. So like we talked about, there's two types of compliance methods. You can either use the ComCheck, which within ComCheck you can select either the energy code or ASHRAE, or you can have an energy consultant do an energy model. So whatever section you choose, you just have to make sure that all of the trades, architect, mechanical, electrical, they all need to use the same version or the same compliance method, because they do differ slightly. And what the authority having jurisdiction is looking for is that a building meets or exceeds a base level. So you need to make sure that the base you're working off of is similar. Each state can set their own energy code, or what version of the energy code. Some are newer, some are older. They're continuously changing. So on the coasts, they tend to be a little bit more stringent. And then in the middle of the country, they are a little bit further behind as far as energy efficiencies. California has their own energy code, which is a whole nother ball of wax that we won't get into today. But you can see it really is ever changing. This is a map. Today is, 2017, but this can change at any time. So before you start a project, you should really check what energy code is being used in the municipality you're working. And you can just do that on the Department of Energy's website. So within the energy code, there are different requirements depending on what climate zone you're in. So it does get a little bit confusing because you first have the energy code, and then within there you have climate zones. So depending on the climate zone, you can have things that stay constant, like lighting. No matter where you are, it's going to be a certain watt per square foot. Now that watt per square foot is going to change depending on what energy code it is, but the climate zone won't affect that. Whereas insulation requirements will change per code and per zone. So it starts to get a little bit more complicated looking that up. So climate zones, you can see, are really based on counties. So you could be right on the line. So you really have to know where your project is to be able to look that up. The other thing that we use a lot in warehouse is semi-heated spaces, and a semi-heated space changes depending on that climate zone also. So for the majority of what we do in the Northeast and Mid-Atlantic, we're either climate zone 4 or 5, but you can be down into climate zone 3 sometimes. So anything over 15 BTUs a square foot in climate zone 4 or 5 is going to push you into a conditioned space, and then insulation requirements are going to change and get much more stringent, and you're going to end up spending a lot of money. So we try and stick with that 15 BTUs a square foot or less in climate zone 4 or 5 to get that semi-heated space. So the other thing is we tend to use ASHRAE more, because ASHRAE is the code that has semi-heated spaces. The International Energy Code doesn't actually have a provision allowing semi-heated spaces. So that's why we end up with ASHRAE quite a bit more. So just looking at some of the different requirements in Climate Zone 4, this is from the 2013 ASHRAE standard. You can see that there's, in a non-residential conditioned space, you have an insulation value on the roof of R30, whereas in a semi-heated space, you'd only need an R10. For mass walls, which are also concrete walls, you have a continuous value of R9.5, but nothing required on the walls. This starts to be a juggling game on how much insulation you need, because we need to stay under that 15 BTUs. So we will probably be over these amounts as far as R10 on the roof and no wall insulation, depending on the size of the building. But it really is a juggling act of trying to figure out the right ratio of insulation to stay below that 15 BTUs a square foot. If we go to Climate Zone 5, we're going to end up with an R15 minimum on the roof, and then a required R5.7 on the wall. So you can see you go from Zone 4 to 5, and all of a sudden the requirements for semi-heated space become greater. Also for the non-residential heated space, you have R30 on the roof, and you're up to R11 on the walls. So not a ton more. So we have a spreadsheet that ARCO has access to, where you can put in the state and county, and it'll pop up the requirements for semi-heated spaces, as far as roof, walls, all that sort of thing. The other thing is with both the ComCheck and the consultant-driven energy model, you're just looking at being more energy efficient than a baseline building. So there are some gives and takes that you can do, as far as a little bit less insulation on the walls or the roof, but a little bit more efficient lighting. An energy model by a consultant has much more ability to provide pluses and minuses. The ComCheck is pretty limited in that. So if you ever get into a bind, it's really sometimes worth going to a consultant to get a full energy model, because you can save a lot in terms of insulation values.